All right, here's a video for notes 2-5 trig word problems. So to start the lesson, I'm just going to show, see if we can find a pattern. If we take the sine of 20, I'm telling you that I can find the cosine equivalent. So the cosine equivalent is going to be cosine of 70. So see how these are equal? And I could do that again. Let's see, sine of 10 is that, and I'm going to say that that's equal to cosine of 80. If you notice the pattern here, I'm only going to do a couple just for the sake of time in this video, that these two numbers always add up to 90. These two numbers always add up to 90, which means the sine of one number is equal to the cosine of its complement, or the number that makes it 90 degrees. So let's see why that works. So here's kind of an example. This is from the warm-up. So we know that A and B have to be complementary. Since this is 90 degrees, we know there's 180 degrees in a triangle. Therefore, the measure of angle B must be 39 degrees. We know that BC is the opposite side of 51, and we know that BC is the adjacent side of the 39-degree angle. So we know that sine of 51 is going to be BC over 8, and we also know that cosine of 39 equals BC over 8 since it's adjacent over hypotenuse. Therefore, by the transitive property, sine of 51, so I'm going to show in the calculator in a second, sine of 51 should equal, sine of 51 should equal the cosine of 39, which it does because those ratios are equal. So if we generalize, this is what we can say. Here we have a triangle. We know that this angle is theta, therefore this angle has to be 90 minus theta. We know that sine of theta is going to be x over z, and we know that cosine of 90 minus theta is going to be x over z. Therefore, we can say that cosine of theta, or sine of theta, has to equal the cosine of 90 minus theta. The way you can say the sine of one number is equal to the cosine of its complement. All right, so now in this lesson, we're going to talk about trig word problems. So when we're doing trig word problems, we need to draw a picture. We need to find our right triangle and label our diagram. And then we're going to solve using trig or inverse trig. Or we can use special right triangles if it happens to be a special right triangle. There is a little bit of vocab involved in word problems though. So those two vocab words or phrases is going to be angle of elevation and angle of depression. So the angle of depression is the angle looking down from the horizontal. So if we have someone up above and here's the horizontal, the angle of depression is this angle looking down at an object on the ground. The angle of elevation is going to be someone on the ground looking up. So that angle is the angle from the horizontal through the line of sight. Okay, the angle of elevation and the angle of depression are always going to be equal. And the reason that they're going to be equal is because these are alternate interior angles, right? We have parallel lines. Here's my transversal. This angle and this angle are alternate interior angles. Okay, so now I'm going to go over these word problems that we did in class. All right, so number one says, a boy flying a kite lets out 300 feet of string, which makes a 38-degree angle of elevation with the ground. There should be a degree symbol there. Assuming the string is straight, how high above the ground is the kite? All right, so here's the string, and it's 300 feet. And we know that the angle of elevation, so from the ground up, is going to be 38 degrees. And we're solving for how high is the kite above the ground, which is this. So here's my right triangle. Now I'm going to use trig. Here's my reference angle. This is opposite hypotenuse, so we're going to use sine. So sine 38 equals x over 300. And just for the sake of time in solving, we know that x is on top, so I know I'm going to multiply. So it's going to be 300 times sine of 38. So 300 times sine 38, we get 184.70. So since word problems have word answers, I'm going to say the kite is 184.70 feet above the ground. All right, number two, it's a problem about a ladder. So it says a ladder leaning against a wall. So here's my wall, and here's my ladder. Makes an angle 74 degrees with the ground. I don't know what happened to my degree symbols. So here's my 74 degree. It says the base of the ladder is 4 feet from the wall. So here's the base. Base means bottom. We want to know how high on the wall is the ladder, meaning what is this length right here. All right, so I have my right triangle. Circle my reference angle. Label, this is my opposite, this is my adjacent. So I'm going to use tan, x over 4. And just like before, x is on top, so my last step is going to be multiplication. 4 times tan, 74. 4 times tan, 74. We get 13.95. So again, word problems have word answers. The ladder is 13.95 feet high on the wall. All right, problem number 3. So it says, again, we have another ladder here. Firemen are using a 15-foot ladder to reach the top of a 12-foot tree to save a cat. All right, so here's my tree. It's 12 feet. The ladder, which we know is slanted, is 15. We want to calculate the distance from the base of the tree to the bottom of the ladder. So base means bottom. This is what we're doing. So here's my right triangle. So we're not going to use trig here. Since we're solving for a length and we're only given sides, we're going to use Pythagorean theorem. So 12 squared plus x squared is equal to 15 squared. So we have 144 plus x squared is equal to 225. Subtract 144. So I have x squared equals 81. And we're just going to take the square root of both sides. Let me just make sure. 15 squared. Okay. Square root of 81 is going to be 9. So I'm going to say the distance from the base of the tree to the bottom of the ladder is 9 feet. All right, the second one says calculate the angle the ladder makes with the ground. So I'm calculating this angle right here. Okay, so since we're calculating an angle, we know that we're going to use inverse trig. So I'm going to use these two sides. This is opposite and this is hypotenuse. So I'm going to use sine. And then since we're solving for an angle, we're going to use the inverse. So inverse sine 12 divided by 15, we get 53.13 degrees. So the angle the ladder makes with the ground is 53.13 degrees. All right, so Javier is making a square-shaped Valentine's card. And we know that the diagonal is 4 inches long. We want to know how long is each side of the card. So you might be looking at this and say, well, we don't have any angle measurements and we only have one side. What are we supposed to do? Well, if you remember, a 45, 45, 90 triangle is made of half of a square. So this is actually a 45, 45, 90. So we can actually use this, solve this using trig, or we can solve this using special right triangles. Just for a special right triangle review, I'll go ahead and solve using special right triangles. So we're solving for the length of each side, and we know that those sides are congruent. So it's going to be x over 1 equals 4 over the square root of 2. And then we cross multiply. So x root 2 is equal to 4 and divide by the square root of 2. So since this is a word problem, I do just want an approximate answer. So actually what we can do without having to rationalize our denominator, we can just say 4 divided by the square root of 2. We get 2.83. So each side of the card is 2.83 inches. You could also do this using trig, right? If this is my reference angle, this is adjacent, this is hypotenuse. So we'd use cosine. Cosine 45 equals x over 4. And we know that we would multiply. So just to show you it's the same thing, 4 times cosine 45, we get the same thing. All right. Next problem here, hot air balloon. So picture's already drawn. It says, show two ways to solve for the height of the air balloon. One's using sine, the other using cosine. So here we have the angle of depression, which we know is going to be equal to the angle of elevation. So I can go ahead and fill that out. So one way I could solve this is using sine. All right, this is opposite, this is hypotenuse. So I'm going to say sine of 62 is equal to x over 90, and we can multiply. So 90 times sine of 62. So we get 79.47. But the second way we can do it is we can solve for this angle. And we know that the sine of one angle is equal to the cosine of its complement. Well, that angle, we know that these two angles are complementary. So I could just do 90 minus 62, 28. This angle right here is 28 degrees. And now using this angle as my reference angle, this is my adjacent side, this is my hypotenuse, I could do cosine. Right, because we know that sine of 62 is equal to cosine of 28. So 90 times, just to confirm, cosine 28, we get the same thing, 79.46. All right, this last problem, a little bit of a challenge problem here. So here we have two triangles, and we're asked to solve for the height of the side. Well, what we need to do is we need to solve for this whole big length right here, and then we need to solve for the smaller triangle, and then we're going to subtract them. All right, so first using the 42, I'm going to solve for x, which is going to be the height from the top of the sign to the bottom of the building. So that's going to be tan. So x over 24. So we know we're going to multiply. So 24 times tan of 42, 21.61. And now I'm going to solve for y, which is the height of just the building. So that's going to be, that angle is going to be 31. Oops, I'm calling that y. So 24 times tan of 31, get 14.42. And then now to solve for just the height of the sign, we need to subtract these. So 21.61 minus 14.42. Get 7.19. So the height of the sign is 7.19 feet. All right, so now let's take a look at the homework. All right, so number 2 says Charlie's designing a square-shaped coaster. The diagonal is 9 inches long. How long is each side of the coaster? So this is similar to the Valentine's card that we just did. All right, oops. Well, it's okay. This is 9 inches. And again, this is a 45, 45, 90 triangle. So you can solve using special right triangles, or you can solve using trig. I'm going to use trig this time. So I'm going to use this angle as my angle. This is my adjacent. This is my hypotenuse. So it's going to be cosine x over 9. So we're going to multiply. So 9 times cosine of 45. 6.36 inches. All right, number 4, it's a special right triangle problem. So this is a 30, 60, 90. So I'm just going to write my other ratios here. The short side we know is 1, the hypotenuse is 2, and then the long side is equal to the square root of 3. So the quick way we can do solve for y is remember that the hypotenuse is 2 times this. So if we divide by 2, that means y is going to be 22. Okay, then we can set up our ratios here. So it's going to be x over the square root of 3 equals 44 over 2. Then we cross multiply. So 2x equals 44 root 3 and divide by 2. So we're going to get 22 times the square root of 3. All right, then we have this last question here. It's two-step. We need to solve for this shared side first, so I'll call it y. So this is going to be tangent, because this is O and A. So tan 48 equals y over 45, and then we're going to cross multiply. So we get y equals 45 times tan of 48. It's 49.98. Okay, now that we have that, now we can use that to solve for x. So using this as my reference angle, this is opposite, this is now my hypotenuse, so OH is going to be sine, and it's going to be x over 49.98. So again, cross multiply, you're going to end up just multiplying. So 49.98 times sine of 51, 38.84.